Hello everyone, I am Sairaj from Group Whisper. This is Whisper's CPP adapter for GLC V1. It's a local offline STT provider that runs Whisper CLI on device. No API keys, no network, no cost. I will walk you through the implementation, the test, and the real audio demo. The three wrapper.py. The first, the pipeline, the adapter.py. Starting with the constant, we have a sample rate up at 16K that Whisper CPP's native format. Byte per second sample is 2 for 16-bit PCM. The critical one is silent maximum amplitude. So silent max amplitude, this is a silence threshold. The original stub was had like a 32, which was way too low. The real world audio embedded noise well like above 32 even in the quiet rooms. So the real speech was being silenced, so we increase it to 500, which is generous enough to let speech through while still catching like pure silence. The WAD threshold 30. So moving on to the PCM payload. So here this extract the raw PCM samples from the WAV file. Whisper CPP expects 16K Hz mono 16-bit PCM, but callers often send WAV containers with ref headers. We use Python wav.open to read the data chunk, stripping the 44-byte header. If it's not valid WAV, we fall back to the raw bytes. This is important because the silence detector need to measure actual audio samples, not the header bytes. So next, moving on to the maximum amplitude. Maximum amplitude, find the peak absolute value in the PCM data. We use array to load the bytes as int 16 samples, then find the maximum. This is how we detect the silence. If the peak is below the threshold as mentioned above in the constant, the audio is silent. Next, moving on to the isSilent function. So isSilent function is a trust boundary. It calls PCM payload to get the raw samples, then maximum amplitude to find the peak. If the peak is below silence amplitude like that was 500, we return true. This short circuits the entire pipeline. We never shell out the whisper CLI for the silent input. The test verifies this by checking that mock's subprocessor call count stays at 0 for silent audio. So next, moving on to the durations. So the durations calculates the audio length in the seconds for WAV files. We read the frame count, sample rate. We read the frame count, sample rate from the header of for a raw PCM. We assume 16K Hz mono. This is used by should use WAD or not. This detect if audio is long enough to warrant the silence streaming. So next, the default for should use WAD is false. So after checking the validation only, we will send should we use WAD or not the true. So next is normalizing Feeble. So normalize Feeble boost quiet speech if the peak amplitude is above the silence floor but below the 2002K, about 6%. We scale it up around 20%. The gain is capped at 10x. To avoid distortion, we preserve the WAV container parameters, channels, samples, frame width, frame rate, so the output is valid WAV file. This helps Whisper detect Feeble that would otherwise be missed. So next, moving on to the strip noise tags. Strip noise tags removes whispers non-speech events. We strip these with regex so the caller only sees the actual text. If stripping leaves only punctuation, we return empty string. Next, moving on to the provider. Now the main transcribe method. First we check the audio is silent or not. If it returns empty result instantly. Second we normalize Feeble voices. Third there is a mock in the config. We delegate to it. Fourth we decide whether to use WAD or not. Fifth we run the whisper CPP model. For the errors, we added called processor error, STTT error, and transcribe. After that, so next moving on to the wrapper.py. So here we are using 4 threads of CPU core. So next it is some silence threshold which is 500, and minimum silence milliseconds which is 3000, like a 3 second of silence detection. So next moving on to the resolve CLI. It will check for whisper CLI binary. If it is present, it will use that. If it is not present, it will switch to the whisper.cpp. So next is a resolve model. So here the model is going to be like said. So we are using both models which are ggml-base.bin and ggml-base.en.bin. This specifically used for the English transcription only. So we are using both here. So next is to find Wayne chunk. So here the WAM file can have extract chunk like list, fact, queue. It's using Python's open wave.open library. So next is a trim silent wave. So this here will be triggered if the silence detection, the silence is more than 3000 milliseconds. That silence will be removed. And moving on to the next is the extraction duration. Whisper CLI has changed. It will get the duration from the output that is done by like a that is present in the JSON output format. So moving on to the next function, which is praise shader transcript. This will be triggered only after the WAD is enabled, like CLI detects like more than some duration more than we gave in the adapter. So next will be the run whisper CPP. Here the model will be running, like all models will be running. So as I said, we are using the base model. So also both like fallback, we are using whisper.cpp as a fallback and whisper CLI now. the whisper in the whisper CLI, like we are using ggml dot base model. So that's it for wrapper.py. So this is my contribution